Welcome to the lesson on key charging terminology. In this lesson, we will explore some of the essential key terms commonly used for electric vehicle, abbreviated as EV charging. Let us look at our lesson objectives. By the end of this lesson, you will be able to identify key terms associated with EV charging. Next, you will be able to describe key terms used for EV charging. Identifying and describing the key terms will enable you to communicate effectively with others about the main charging concepts. There are several terms associated with EV charging. In this lesson, we will focus on some of the main charging key terms for EVs, namely Level 1 charging, Level 2 charging, and DC fast charging. We will compare Levels 1, 2, and DC fast charging and describe superchargers, followed by a description of wireless charging. We will also focus on the electric vehicle supply equipment, abbreviated as EVSE, or the charging station, the charging connector, and the charging infrastructure. By the end of this lesson, you will gain insights, understand the significance, and grasp the importance of these key concepts in EV charging. Just like how you connect your devices, such as smartphones or tablets, to a regular wall outlet at home, Level 1 charging for EVs involves plugging the car into a regular household power outlet using a special charging cord. Level 1 charging for an EV uses a standard household outlet 120 volts alternating current, abbreviated as 120 volts AC. This is the slowest form of charging as it takes approximately 40 to 50 plus hours to fully charge an EV. It is commonly referred to as trickle charging due to its slow charging speed. It does not give a quick burst of power and is therefore suitable for overnight charging or when a longer charging time is available. It is commonly found in domestic outlets and outlets in household garages. Level 2 charging can be compared to using a faster charger for your smartphone or tablet. Instead of plugging your device into a regular wall outlet, you use a special charger that provides a quicker charge. Level 2 charging for EVs involves using a dedicated charging station that provides a faster and more efficient charge compared to Level 1 charging. It is like having a powerful charger for your car that can recharge the battery faster, allowing you to get back on the road in less time. Level 2 charging utilizes a higher powered charging station operating at 220 to 240 volts AC. Level 2 chargers provide faster charging compared to Level 1. Level 2 charging can take approximately 4 to 10 hours to reach 80% charge. Level 2 charging stations are commonly found in workplaces, and public charging stations such as offices, grocery stores, leisure facilities, car parks, and residences that are equipped with dedicated circuits for 240 volts AC. You may have noticed that when you stop at a gas station for a quick fill-up, you can refuel your car with gasoline in a matter of minutes. Similarly, direct current, abbreviated as DC, fast charging for EVs, offers a rapid charge that can significantly replenish the battery in a short amount of time. It is like making a pit stop during a long road trip where you can quickly charge your EV while taking a break, ensuring you have enough power to continue your journey without an extended waiting period. DC charging uses direct current and provides a high-powered charge directly to the vehicle's battery. This fast charging offers rapid charging capabilities. DC fast charging can replenish an EV's battery up to 80% in just 20 minutes to an hour. DC fast chargers are typically found at public charging stations along highway rest stops, gas stations, shopping centers, malls, public parking facilities, hotels, and resorts. Superchargers provide an ultra-fast charging experience for EVs. Tesla vehicles have access to a proprietary fast charging network called superchargers. These high-powered DC fast chargers are designed for Tesla battery electric vehicles, abbreviated as BEVs, and provide fast charging speeds for Tesla owners. Tesla has opened its supercharger stations to non-Tesla electric car owners. On average, Tesla superchargers are designed to deliver fast charging speeds, allowing Tesla vehicles to gain approximately 200 miles of range in just 15 minutes of charging. However, it differs among Tesla models, and the charging time may vary. They are typically located along major highways and popular travel routes. Tesla provides online maps and navigation systems to locate the nearest supercharger station based on a driver's current location or planned route. Here we have a table comparing the different charging, namely Level 1, Level 2, and DC fast charging. Level 1 charging is the most basic. typically using a standard household outlet. The voltage for level 1 charging is 120 volts AC, and the typical power output is 1 kilowatt. It takes around 40 to 50 hours to fully charge an EV from empty using level 1 charging, providing an estimated electric range of 2 to 5 miles per hour of charging. Level 1 charging is commonly done at home. Level 2 charging offers faster charging times compared to level 1. It requires a dedicated charging station or an outlet with higher voltage, ranging from 208 to 240 volts AC. The typical power output for level 2 charging is between 7 and 19 kilowatts. With level 2 charging, it takes around 4 to 10 hours to fully charge an EV from empty, providing an estimated electric range of 10 to 20 miles per hour of charging. Level 2 charging can be found at home, workplaces, and public locations. DC fast charging provides the quickest charging times for EVs. It operates at high voltage, typically ranging from 400 to 1000 volts DC. The power output for DC fast charging is significantly higher, ranging from 50 to 350 kilowatts. With this level of charging, it takes approximately 20 minutes to 1 hour to charge an EV from empty, offering an estimated electric range of 180 to 240 miles per hour of charging. DC fast charging stations are commonly found in public locations. Please note that charging speed is affected by many factors, including the charger manufacturer, condition and age, air temperature, vehicle battery capacity, and vehicle age and condition. You may have noticed that as technology has advanced, our everyday smartphones can now be charged on a wireless charging pad. Just as you can conveniently charge your phone by placing it on the charging pad without wires, wireless charging for EVs eliminates the need for physical connections. Wireless charging technology enables charging without the need for physical cables. It uses an electromagnetic field to transfer energy from a charging pad on the ground to a receiver pad on the vehicle, allowing for convenient and cable-free charging. On average, wireless charging systems for EVs can take 3 to 8 hours to fully charge, depending on the charging power and battery capacity. Wireless charging infrastructure is still being developed and is not as widely available as traditional charging stations. The adoption of wireless charging technology is gradually increasing, and as the demand for EVs grows, we can expect to see more wireless charging in various locations, in addition to parking lots and public charging stations. Just as you go to a gas station to refuel your car with gasoline, a charging station is a designated location where an EV battery can be charged. It is like pulling up to a dedicated station specifically designed to provide the energy needed to power an EV. EV supply equipment, abbreviated as EVSE, commonly called charging stations, are typically equipped with charging equipment, cables, and connectors that allow you to connect and recharge an EV battery, like how you connect a gas pump to your car's fuel tank to fill it up with gasoline. Charging stations are strategically placed at various locations, including parking lots, shopping centers, highways, and residential areas, to provide EV owners convenient access to charging infrastructure. They are designated locations with the necessary infrastructure to charge EVs. Think of them as fueling stations for EVs, but instead of pumping gasoline, EVs are connected to an external power source to recharge their batteries. They come in different types, offering varying charging speeds and capabilities. This means EV drivers can choose the charging option that suits their needs, whether for a quick top-up or a longer charging session. Just like how you use a specific connector to charge your smartphone or tablet, a charging connector for EVs is a specialized plug that allows you to connect an EV to a charging station or charging cable. It is like using a specific charger with the right connector that matches your device, ensuring a secure and reliable connection for charging. Charging connectors come in different types and standards, depending on the region and the type of charging infrastructure. Just like plugging in your electronic device, you simply plug the charging connector into an EV, and it establishes the connection for transferring power from the charging station or cable to charge the EV's battery. A charging connector is used to connect the charging cable to the EV's charge port. It ensures a secure and reliable connection between the vehicle and the charging infrastructure, enabling the transfer of electricity for charging the EV's battery. EV charging connectors are available in different types and standards, such as CHAdeMO, pronounced charge de move. This is a Japanese phrase that, in English, translates as a charge for moving. CHAdeMO is the trade name of a quick charging method for EVs. It uses a proprietary charging connector system. It is a specific type of charging connector and protocol designed for high-powered DC fast charging, primarily used by Japanese automakers. It enables efficient and rapid charging at dedicated CHAdeMO charging stations, offering an alternative charging option for compatible EVs. Another EV charging connector available in different types and standards is a combined charging system, abbreviated as CCS, that depends on the region and the specific charging requirements of the vehicle. While CHAdeMO was initially popular for its early adoption and widespread availability, the CCS standard, which combines AC and DC charging capabilities, has gained significant traction globally. However, many CHAdeMO-equipped EVs can still utilize CCS chargers using adapters or dual standard charging capabilities. The Tesla North American Charging Standard, abbreviated as NACS, is a proprietary EV charging connector system developed by Tesla Incorporated. It has been used on all North American market Tesla vehicles since 2012 and was open for use to other manufacturers in 2022. It is smaller and more compact than other charging connectors, such as the CCS. Adopting the North American Charging Standard is a major step towards North America's more unified charging infrastructure. It makes it easier for EV owners to charge their vehicles, regardless of the make or model of their car. This charging infrastructure is like the network of gas stations that enables drivers to refuel their cars wherever they go. It ensures that EV owners have access to charging points, allowing them to recharge their vehicle's battery and extend their driving range. Just as you plan your trip by considering the availability of gas stations, having a well-developed charging infrastructure ensures that EV owners can confidently travel and recharge their vehicles as needed. EV charging infrastructure comprises a widespread network of charging stations located in public areas, including highways, parking lots, and urban centers, ensuring convenient access to charging for EV owners. Charging infrastructure provides various charging options to accommodate different needs. It includes Level 1 and Level 2 chargers for home and workplace charging, and DC fast chargers that offer rapid charging for longer journeys or when quick recharging is required. EV charging infrastructure follows industry standards to ensure compatibility and interoperability across different EV models. Common charging connectors like CHAdeMO, Combined Charging System, and Tesla Superchargers allow EVs to charge seamlessly at different charging stations, promoting widespread adoption and convenience for EV drivers. In this lesson on key charging terminology, we discussed the key terms associated with EV charging. We also discussed Level 1 charging, a slow charging option that utilizes a standard household outlet, 120 volts AC. Level 1 charging is convenient for overnight charging at home, gradually replenishing the EV's battery over several hours. Next, we spoke about Level 2 charging, a medium-speed charging solution using dedicated charging equipment, 208 to 240 volts AC. Level 2 chargers are commonly found at home, workplaces, and public locations such as parking lots and shopping centers. This type of charging provides faster charging times compared to Level 1, allowing EVs to charge up in a few hours. Moving on, we looked at DC fast charging, a high-speed charging method designed to charge electric vehicles rapidly. DC fast chargers supply a high-voltage DC to the EV, enabling quick battery replenishment within 20 minutes to an hour. These chargers are typically found at highway public charging stations, allowing drivers to charge their EVs during long trips and reduce downtime. We discussed superchargers, which are Tesla's proprietary high-powered DC fast charging network. Superchargers were designed specifically for Tesla EVs but are available to all EV owners. Superchargers provide rapid charging capabilities. They utilize high-voltage DC to quickly replenish the battery of Tesla EVs, allowing drivers to significantly reduce their charging time and get back on the road more swiftly. Next, we compared 3 types of charging, highlighting their varying charging speeds, voltage levels, and locations. Level 1 charging is convenient for overnight charging at home. Level 2 charging provides a faster option for everyday charging needs, and DC fast charging offers a rapid charging solution for quick top-ups during long journeys. We touched upon the concept of wireless charging. This innovative technology enables EVs to charge without the need for physical cables. Wireless charging systems utilize electromagnetic fields to transfer energy between a charging pad or ground-mounted charger and the EV's receiving coil, typically installed underneath the vehicle. The charging process is initiated by parking the EV over the wireless charging pad or within proximity, and energy is wirelessly transferred to the vehicle's battery. Wireless charging offers convenience and ease of use, eliminating the need for plugging and unplugging cables and streamlining the charging experience. Thank you.